In this video, we will talk about the value of protease. Plant-derived protein is widely used in feed, but its complex protein structure and high content of anti-nutritional factor lead to low digestibility of plant protein from animals, decomposition of macromolecular protein, and degradation of anti-nutritional factors are the final value embodiment of protease. The protein content of different raw materials is different, and the XID of peaks for different raw materials also varies from 60 to 95%. That is, 5 to 40% of the protein in the raw materials cannot be digested by animals, most of which are the anti-nutritional factors we mentioned. Here are the three main anti-nutritional factors: prolamine, soybean antigen protein, trypsin inhibitor. Many raw materials contain prolamine, which accounts for a very high proportion of protein. The protein structure of prolamine contains a large number of hydrophobic amino acids, and there are disulfide bonds and hydrogen bonds between molecules, so it is difficult for animals to absorb and use it, which greatly reduces the utilization value of feed raw materials. Prolamine forms absorption or embedment on the surface of starch granules, thereby reducing the contact and the enzymatic hydrolysis of starch by enzymes, inhibiting the catalytic degradation of starch by amylase, and reducing the digestibility of starch. Prolamine is stable in acidic environment, but easy to be decomposed in neutral and alkaline environment by protease. Therefore, neutral protease can play a very good role of degradation in small intestine. It can not only decompose macromolecular proteins into small polypeptides and amino acids, but also release starch granules, improving energy utilization. Soybean antigen protein refers to some macromolecular proteins or glycoproteins in soybean and its products that can cause allergic reactions to human or livestock and poultry. There are 32 kinds of soybean antigen proteins that have been confirmed, among which glycine and beta-conglycine are the soybean antigen proteins with strongest immunogenicity, accounting for 65% to 80% of the total soybean seed protein, and are the main antigen proteins in soybean. The sensitization mechanism of soybean antigen protein on early Y pylix intestinal tract. After the antigen protein enters the small intestine, it causes the sensitized hypertrophic cells to release histamine, and histamine causes diarrhea in pigs, thus inducing whining syndrome of piglets. It is verified by experiments that Botemei XP can rapidly and efficiently eliminate soybean antigens, maintain the integrity of intestinal valley, and improve the digestibility and absorption of nutrients after enzymolysis at 40 Celsius degrees for 1 hour. Trypsin inhibitor refers to a kind of substance that can inhibit the combination of protease and substrates, so as to reduce or even lose the activity of protease. According to its structure, it can be divided into kinase trypsin inhibitor and bound-bulk protein inhibitor. Raw soybean contains 1.4% KTI and 0.6% BPI. 40% of the anti-nutritional effects of raw soybean is caused by trypsin inhibitor. Raw soybean contains trypsin inhibitor, which stimulates intestinal mucosa to secrete cholecystokinin, causing pancreatic enlargement and hyperplasia, and also inhibits the activity of trypsin and chymotrypsin. Due to the excessive secretion of pancreatic juice, the excretion of fecal nitrogen increases, which leads to the deficiency of some amino acids, thus affect the growth and development. Although the trypsin inhibitor is sensitive to temperature, Botemei XP can still eliminate the trypsin inhibitor in soybean meal, soybean cake, and fermented soybean meal, and increase the trypsin activity by 18 to 55%. We adopt in vitro biomimetic test method, set up blind control and control group to test the digestion effect of different proteases on gluten and DDGS. It can be seen from the figures that the protein digestibility of Botemei XP for gluten and DDGS are significantly better than that of other proteases, which greatly improves the use value of feed. Take DDGS as an example. The protein content is 28%. The price is $500 per ton. the digestibility of the control group is 70.27%, and that of Botemei XP group is 79.06%. That is, adding Botemei XP can increase the digestible protein by 2.46%, saving the cost by $60 per ton. Conclusion: people eliminate anti-nutritional factors in feed by expanding, cooking, baking, fermenting, and other methods to improve the digestibility of various nutrients in raw materials. Different anti-nutritional factors in raw materials require different treatment processes, but each of every process requires a certain processing cost. The more processed the raw materials contained in the formula, the higher the feed cost. For improving the digestibility of nutrients, enzymatic hydrolysis technology is undoubtedly the most direct and effective treatment method. As a protease with broad-spectrum substrate, strong adaptability, and strong enzymolysis, Botemei XP can greatly improve the digestibility of raw materials and reduce the cost of raw materials, whether it is simply hydrolyzed by raw materials in vitro or cooperated with endogenous protease in vivo. Therefore, Botemei XP is the best choice to reduce costs and increase efficiency. Reducing cost and enhancing efficiency is the direction that feed companies are always pursuing. Botemei XP is willing to go hand in hand with you. More research results will be updated soon, so stay tuned.